Hi everybody. So today we're going to finish off our discussion of energy by talking about solar, geothermal, wind, and a little bit about hydrogen fuel cells. So these are our sort of newer renewables. Okay, so just to kind of go back and remind you that these renewables are really right now only a small slice of the total. So notice even the way this graph is made, bioenergy and hydropower, which we've already talked about, actually account for most of this little piece. And so wind, solar, and geothermal are much smaller overall portion of our total energy consumption and our electricity use. So one of the things to think about as we go through this is how can we make that chunk a bigger proportion of the total. Okay, so if we look at their growth though, they are growing faster than some of the more traditional energy sources, but since they're such a small percentage to begin with, we really haven't seen this cut into the overall energy consumption that much yet. All right. What is the benefit of these renewable sources? So here's just one. This is light greenhouse gas emissions. So obviously we're worried about climate change. And if you look at all these renewable sources, right, in general, much lower than especially the fossil fuels here. All right. You may notice on biomass, there's pretty big range here. So you should be able to figure out why biomass in particular would sort of vary in its CO2 emissions. All right, but why don't we use these if they don't generate emissions? Well, here's kind of the reasoning behind that. Some of it's just we develop fossil fuels first, and that's what our systems are set up for. But obviously cost is also an issue. And you can see that, so here's the gold area is the range of non-renewables. And the renewables are mostly going to be more expensive, though there's becoming more and more overlap as we develop the technology. Okay, so let's start talking about solar. So solar power can actually be harnessed in a few different ways. The two ones that we're going to focus on here is using photovoltaic cells, which are going to produce electricity from light. And these are probably most of the solar cells you see on rooftops or parking lots or out in fields. All right, but solar energy can also be used more directly for solar heating. So making hot water, for instance, can be an example of that. And that can be either active, which you're using pumps to circulate heat gathered, let's say from a rooftop collector, or it can be passive. So how do you design your house? How do you place the windows? What kind of exposure do you get? What kind of insulation do you use? And there are materials that you can use that actually capture, for instance, more of that thermal energy and then release it slowly throughout the day. And so these are things, if anybody's interested in architecture, engineering, you can think about. All right, here's a diagram of basically that active solar heating. So you've got the sun, it's heating some type of solar collector, and then basically you're pumping water or some other fluid through that. It heats up and it can heat up water that then goes to either heat various things or just makes hot water. Okay. And this can be used on a variety of different scales, and you can also concentrate sunlight over a large area using like mirrors or this parabolic dish. And so that makes it even hotter. And so if you actually look online, you can find directions how to make a solar oven using aluminum foil, and you can put it outside and see how hot you can actually get it. But if you engineer it correctly, you can actually get fairly high temperatures. All right, and here's an example of a photovoltaic cell. So here the sunlight's being captured, and we're using a semiconductor like silicon to actually convert that to electricity. And this can be used obviously to power your house. And if excess is generated, it can actually be fed into the electric grid. Or if it's a large solar farm, it can be used to basically feed into the electric grid. All right, so here are advantages, right? Low CO2, almost none once it gets up and running, high net energy gain. they can really, since there's a variety of different types, it can be used at all sorts of different scales. So it can be a power plant scale where you're getting a huge amount of energy, or it can just be like one house. It can be used in more rural areas where there is no electric grid. So in developing countries, it can be useful. Think of the disadvantages though. So one, you need sunshine and fairly, enough high sunshine hours that it's worthwhile. It's still going to be an intermittent resource. So what do you do when the sun's not up? So you need some sort of battery or backup system is going to be required. And then as far as ecosystem impacts, the impact here is really, let's say you're putting these in the desert, which is where there's a lot of sun. Well, then all of a sudden you've changed that ecosystem where there's a lot of shade, or you're taking up a lot of land. Okay, geothermal. So this one may not be as familiar with you to you. So this is basically using heat stored in the Earth's interior. And it can be used sort of on two scales. So large scale is like a power plant. And for this, you need basically an area that's more volcanically active. So you need the heat basically to be heating the groundwater. And so this is areas where you think there might be geysers, for instance. And so you're going to take advantage of that steam production by tapping into the groundwater. So this can only happen in certain parts of the world. Geothermal heat pumps, on the other hand, can be used anywhere. And this is basically a heat exchange method, because underground is going to stay steadier in temperature. During the winter, it's going to be warmer, and in the summer, it's going to be cooler. So using that heat exchange can be used as a heat pump. Okay, so this is just showing in the US. Really out west here is where using geothermal energy for a power plant would be useful. And there's a very big power plant in California that does use it. But over in the coast where there's large populations, really not quite as useful. All right, and this is just showing basically, again, we want to tap into this confined water that's being heated by the magma underneath. And so this is generating steam, which we can use to turn a turbine. And what they do now is try to cool that and then return it so that you're not sort of using this resource up. So how this power plant is designed is going to really tell you long-term effects on how renewable it is. Okay, and then here's a diagram showing this heat exchange that you might use. So there are houses in this area that use geothermal. I have a friend who has geothermal. And so they put these pipes underground. And so in the summer, it's going to be cooler. So you use a heat pump to basically pump water, and it's going to get cooled off. And in the winter, it's going to be warmer underground, so it can actually warm up the house. And so the heat pump exchanges that temperature. All right, and again, here's our advantages. So again, low CO2 emissions, depending on the area. So like Iceland has a lot of volcanic activity, so they use a lot of geothermal energy, and it's actually low cost and efficient there because it's in a good area. Basically, those like heat pumps, once they get going, they're pretty efficient, but you have to install them. So it's high startup cost. They can release hydrogen sulfide, for instance. You have to be careful about land subsidence. And then we talked a little bit about you have to manage it so that that water table does not get depleted. All right, wind power. This is increasingly reliable and cost effective. So wind farms are now sprouting up, and you think even the US, okay, where is it windier? Well, maybe like prairie areas, some mountainous regions can be windy. And a lot of growth in this is actually an offshore wind farm. So the wind here tends to be more consistent and less turbulent than it would be on land. You might think back to that Earth Systems chapter. Where does wind come from? Why do we have winds? So wind is actually ultimately comes from the uneven heating from the sun. Many European countries use a lot of wind power. So Denmark is actually the leader. So if we look at wind, this is probably the easiest maybe to understand, that wind turbines use the kinetic energy of moving air. So this spins, and that's going to basically turn turbines, which generates electricity. And here are two graphs. So you have to, when you look at graphs, always read the captions carefully. So this first one, you might look and say, oh, the United States has a lot of wind power. This is just the percentage of global wind power in each nation. So the larger nations have a lot just because we also use much more electricity. Okay, but if you look down here in proportion of electricity that you get from these sources, Denmark gets almost 40% of its electricity from wind power. So that's why I said in the previous slide, Denmark was one of the world leaders. Okay, and this is a growing issue. So as I said, offshore wind farms are in planning process. There's a big one off Block Island, which is actually used to provide electricity for the island. And this is a political issue in Maryland. So there's, and I believe this is moving forward, where there are companies that are going to build wind turbines off the coast of Ocean City. But Ocean City was against it because they thought it was going to ruin their skyline, basically. They thought people wouldn't want to see wind turbines in the distance. So that's still been a little controversial, but I think it's going forward. So here's our wind power advantages and disadvantages. Little ground disturbance, no emissions. This can also be used on a variety of different scales. So you can have small ones, you can have large ones. Again, can be used in many areas. Farmers and ranchers can make money by leasing the land, and so they can make some income off that. It does require steady winds. And it can, one of the environmental impacts is that a lot of birds and bats, for instance, might fly into them. So one of the things that can be done to mitigate this is try to avoid flight paths of flying animals. So don't put them up in migration routes, for instance. But this is something that environmentalists are concerned about. And as I said, most of the cost is startup cost. And you need some backup systems similar to solar when it's not windy. All right, and the last thing I want to talk about is hydrogen and fuel cells. So this is basically a way to store energy. So hydrogen is the most abundant element, but there's not a lot of it as hydrogen. So one of the things about hydrogen fuel cells is you have to figure out how to get the hydrogen. So there's an input of energy to maybe, let's say, break water apart to get the hydrogen that way. But then once you have the hydrogen, all right, you can have a hydrogen battery and it can hold a lot of energy. And the only thing it releases is basically water. So if we look here, hydrogen goes in and our outputs are literally just water, okay? So this is a clean battery. It doesn't need to be recharged. You just need to supply it with hydrogen. So one of the things about hydrogen fuel cells to ask is, where is the hydrogen coming from? If it's coming from burning coal that you need to split water, that's probably not going to be as useful. But if you can use, let's say, one of those other renewable resources to generate the hydrogen, and then use these in, let's say, vehicles as a hydrogen fuel cell battery to power the car, then you're getting to a point where you have very clean energy, okay? So here are the advantages and disadvantages. We're never going to run out of it because hydrogen's so prevalent. It may produce few greenhouse gases. It can be energy efficient, silent, right? You do have to worry a little bit about how you store the hydrogen. So hydrogen can explode. It's expensive and energy is needed to create the hydrogen gas. So how this is done is going to play a role. And there's really not a lot of infrastructure. So it doesn't fit in with our like gas powered cars at the moment. Okay. And then one of the things to think about is, well, can we actually make this transition from fossil fuels to renewables? And this graph is sort of pointing out a couple of things have to happen. So you have to increase efficiency and reduce demand, so get rid of fossil fuels from that point of view, and then replace them, on the other hand, with more renewable energy sources. So either one of those two things will shrink that fossil fuel usage. All right, I just wanted to point up, remember your energy conservation. So these are things we talked about on the last slide. And then go back to that initial question. How can we encourage the switch to renewables. So these are some ways, and we'll talk about them probably in a little bit more detail later. Okay, that's it for today.